A friend of mine asked me to help him pick a gaming computer for his son, so I said no problem and I started looking at pre-builds. But whenever I looked at any of them, I found out that each had some major flaw, like insufficient cooling, not good enough power supply, or a missing front USB Type-C connector. So I suggested that I'd pick the components myself and assemble it. He said great, just make sure it has RGBs, it's black, and that it has Wi-Fi. And I said no problem, and with the budget that he gave me, I went shopping, and this is what I bought. I bought it from 5 different shops to make sure I'm always getting the best price for each of the components. And in this video, I'm going to talk about the alternatives I was considering when picking them. Then I'm going to assemble this PC and talk about the gaming experience you can have with it. You can use this if you're building a similar PC on a similar budget, or if you just like computer hardware. So without further ado, let's start with the CPU. At the time of making this video, there were 2 really good CPU options available: Core i5-12600K and Ryzen 5 5600X. When I was deciding which one to go for, I had to take into consideration my whole budget for the PC and decide if I'm going to spend more on a higher performing CPU, which would have been Intel in this case, or on a higher performing GPU, which would have been 3060 Ti instead of 3060. Because there was a price difference of $150 to $200 US if I wanted to go with Intel instead of AMD. When deciding, you always have to look at the cost of the whole platform, which includes the motherboard and memory modules as well. In case of Intel, I'd have to go with more expensive motherboard with Z690 chipset, and I won't be able to take advantage of DDR5 memory. This was out of question. I'd have to spend somewhere north of $300 US for a 16GB kit. And due to their currently sky-high prices and low availability, I'd have to go therefore with DDR4 memory, so I decided to skip it. As you see, I decided to go with Ryzen 5 5600X and a motherboard with B550 chipset, and therefore spend less on the platform and spend more on the GPU. But if your budget allows it, you definitely won't make a mistake if you go with Intel and 3060 Ti. And this gets us to the motherboard, so let's take a look at it. Because I've had a good experience with Gigabyte Aorus boards, I decided to go with Gigabyte B550 Aorus Elite AXV2, which has a good VRM and an integrated Wi-Fi and allows connecting front USB Type-C connector to your case, which is important and not many boards at this price range have it. I went with B550 board instead of X570 because this computer is not going to be upgraded by any PCIe cards in the next 3 years, which is its planned moral lifespan, maybe with an exception of 2 additional RAM sticks, but that's it. So this was a logical choice. If you don't need a Wi-Fi and you have an Ethernet connectivity, you can save about $30 and get a non-AX version of this board, Gigabyte B550 Aorus Elite V2. But if you are someone who's planning on upgrading their PC with PCI Express cards or Gen 4 M.2 SSDs, then you should go for an X570 board or X570S board, which has passively cooled chipset heatsink and which will set you back $50 more. But it will also give you more connectivity from the chipset to the CPU. It will give you 4 PCI Express 4.0 lanes instead of 4 PCI Express 3.0 lanes in case of B550 chipset. But if you don't plan upgrading, then B550 is good enough. So let's now move on to the memory modules. For gaming, 16GB is still enough, and in case of desperate need, you can easily upgrade it. I decided to go with a dual channel Crucial Ballistix DDR4 kit, which has 2 8GB memory sticks, running at 3600 MHz, which is a sweet spot when it comes to performance for Ryzen CPUs, and has a very good timing of CL16, 18, 18, 38, and is priced very reasonably. If you want to save, you can go with a non-RGB version, which is about $10 to $15 cheaper, but I wanted the bling and it was my assignment. As an alternative, you could very well go with G.Skill Trident Zenio memory modules, which offer similar performance, but at the time of me shopping for them, they were more expensive than these crucial ones. So I decided to go for them. If you're thinking of going for memory modules which have higher timings or lower frequency, then think twice, because the price difference is really small. It may be $15, $20, and this is a long-term decision, so I'm not sure that it would be worth it. So that's why I decided to stay at this sweet spot, which is 3600 and CL16, and I wouldn't change it. So let's now move on to the GPU. This was the most difficult choice because it impacts the whole budget most. It is the most expensive part of the whole PC build, but it has also the most impact on FPS in games, and my philosophy on gaming is simple. I like high FPS and maximum detail over high resolution and lower FPS. I'm willing to give up resolution, so this whole build is intended for 1080p gaming at high FPS and maximum detail. I wanted this PC to be at least somewhat future-proof, although I know it's an impossible task. But with lower resolution, you can achieve higher FPS for longer time into the future. If I had a budget for RTX 3070 or higher GPU, I'd go for 1440p monitor, but in case of 1080p resolution, I'll be able to get higher FPS without decreasing the level of detail. Because the GPUs have the most impact on the FPS in games, I was deciding between RTX 3060 and 3060 Ti. I wanted an nVIDIA graphics card because it has DLSS technology and ray tracing and allows me to increase FPS in games at almost no loss in picture quality, and ray tracing looks simply amazing. I hope you've seen Cyberpunk 2077 with it. Also, these GPUs have G-Sync for synchronization of FPS in games with the refresh rate of the monitor, so it's smooth and you get no headaches even when playing for several hours. When it comes to picking which exact model of 3060 Ti to get, I didn't have much choice. There were only 3 available, and I went for ASUS card because I have good experience with them. They prove to be reliable over time and they are not too noisy. I went for 3060 Ti because it has 1280 more CUDA cores than 3060, and it has also wider bus. This one has 256-bit memory bus over 3060, which has 192-bit bus. So this was a logical choice and I was happy that I was able to get it. Now let's take a look at the SSD. The SSD affects mostly loading times in games and other applications, including the OS. Better SSD won't get you more FPS in games, but it can shorten the loading time. What is also important is its durability, or in other words, how much data you can write to it before it dies. The durability is often overlooked because people mostly look at speeds and capacity only. When it comes to price to performance, it changes as the prices of the SSDs are going down. This Corsair MP600 used to be a high-end drive a year ago, and now it's a mid-range drive which sells for $100 less than I bought it for myself into my video editing workstation. When it comes to drive options, there are 3 main available, and that is SATA SSDs, Gen 3 NVMe SSDs and Gen 4 NVMe SSDs. Because the price of SATA SSDs is close to what Gen 3 NVMe SSD cost. They don't make much sense anymore, and that's why I was choosing only between NVMe SSDs. When it comes to capacity, I would be installing both the OS and the games on the same drive, so the minimum capacity for me was 1 TB, so that's why I decided to go for this MP600 at 1 TB capacity. I was also considering other options, so if I wanted to save, I'd go for Gen 3 M.2 SSD Patriot Viper VPN 100 at 1 TB capacity, which has a good speed and durability of 800 TB writes. If I, on the other hand, wanted something faster, I'd go for the fastest game drive available, which would be Seagate FireCuda 530 at 1 TB capacity, but I'd have to spend $30 or $40 more compared to MP600, which I chose, and I'd have to give up some endurance. So I decided to go for the middle option. When it comes to power supplies, I wanted a high quality power supply with stable power delivery and which has gold power efficiency rating. The prices of electricity have risen over the last year. They almost doubled in Europe, so it makes sense more than ever. So I went for this Seasonic GN750. I went for a 750 watt unit because it is recommended by the manufacturer of the GPU, in this case ASUS or NVIDIA, and because it allows the power supply to operate closer to the middle of the power efficiency curve during the load, and which is where the power supplies are most efficient. I went with Seasonic because I already have a good experience with them, and I'm currently running 3 different models in my other PCs. But if I was considering an alternative, I'd go for Corsair RM750 or EVGA SuperNova 750 G5. When it comes to cooling of the CPU, I went for Arctic Liquid Freezer 2 240 ARGB, which is an AIO. I was also considering air coolers like Noctua NHD15 and Zalman CPUZ 20X. But I decided to go for this one because it has a large radiator which will be placed at the top of the case, and it will help with the exhaust heat from the GPU, especially during long gaming. So I saw this as an added benefit. Plus this kit has RGBs in it, which was something I was supposed to put into the case. And it is also reasonably priced. It is similar priced to NHD15 and CPUZ 20X, and for a 6-core CPU it is absolutely adequate. If you want, you can also get a non-RGB version for about $15 less, that is if you don't like the RGBs, but I think most gamers will prefer the RGB version. This one is also one of the cheapest liquid coolers on the market, and it offers good performance and is priced very reasonably. When I was deciding which case to go for, I wanted something with good airflow and which uses 140mm fans for intake, because they can run at lower speed than the smaller fans while delivering the same amount of airflow. Then I wanted to use water cooling placed at the top of the case, a radiator, so it had to be ready for it. It also had to have a USB Type-C port, because most new smartphones and external SSDs use this type of connector. And lastly, I wanted a reasonably large case, so I went with a smaller mid-tower case with a tempered glass panel window from the side to make sure you can see your components and RGB lights inside while it's running. Next good options I was considering were Lian-li Lancool II Mesh RGB and Corsair 4000D Airflow, which would have both been really good alternatives. So it was a matter of current pricing and availability that I went for this Be Quiet Pure Base 500DX case. And finally, let's talk about the gaming display. I went with this DELL S2522HG, which is a 24.5-inch monitor and has 1080p display with IPS and runs at 240 Hz. It is also G-Sync and FreeSync compatible, so it can take advantage of the RTX 3060 and its G-Sync compatibility. Settings can be easily adjusted by software directly from OS. It also has a height adjustable stand and a USB hub, which allows connecting up to 4 USB ports on the monitor, which are at the bottom, and it also has a headphone jack there. When it comes to the I/O, it has two HDMI 2.0 ports and one DisplayPort version 1.2. The input lag on the monitor is very good, it is around 5 milliseconds. Basically all these parameters are great, and I wanted something with a modern design which includes slim bezels and a reasonably sized chin. And for a 240 Hz display at this price point, I really couldn't find any real alternatives, so that's why I went for it. Monitor was the last, so now is the time to assemble it. Now let's take a brief look at the performance. To have some comparison, I ran CPUZ Benchmark and got 634 points in single thread and 5085 points in multi-thread load. I submitted my results and got what you see here. The reason why my results are above average is that I enabled PBO, Precision Boost Overdrive, in BIOS, and that the water cooling had no problems keeping the temperatures below 70 degrees Celsius, so I was able to use its full potential. I ran AIDA64 Extreme to get some information about the memory performance. In a read speed test, I got 51,000 megabytes per second, which is adequate when using 3600 MHz memory modules in dual channel. I was pleasantly surprised by the low latency of 59.6 milliseconds, which is about 20 milliseconds slower than when using 4 DIMMs. I also ran FP64 ray trace test, which I use as a quick stability test. If your memory or overclock isn't stable, this is one of the tests which would fail immediately. To test multi-core performance, I ran Cinebench R20. The CPU also scored above average here. If you don't have water cooling, you'll likely get a lower score with the same CPU. I have tested several 5600X CPUs with different coolers, so I know that cooling has big impact on the results. Then I checked if the Gen 4 SSD Corsair MP600 has enough bandwidth and if it's being cooled appropriately. I reached expected values, maybe a little bit better. The temperature rose only by 10 degrees Celsius from 30 to 40 degrees, so everything is fine here. Then I ran some games for a few hours as a stability check to see if the FPS is where I wanted it to be. The monitor allowed displaying its current frequency, which was being synchronized with FPS in games. I ran all games at maximum detail settings they allowed, and I had 240 Hz enabled in Windows and G-Sync in NVIDIA drivers. The combination of G-Sync compatible monitor and the GPU worked absolutely flawlessly. I was getting around 100 FPS all the time, and during the cutscenes the monitor switched automatically to 240 Hz, so gaming was really smooth with these settings. Then I took a look at older games which would allow me to run at full 240 Hz all the time with all details enabled. Everything looked great and moved without any glitches. I took a look at 2D game Command & Conquer Remastered to see how the monitor behaves during scrolling. Everything was very smooth, which was expected, but one has to test it to be sure, so I did it. I found out I enjoyed playing this old game with upgraded graphics. I still remember when it was released for the first time. I played it a lot back then. And the last game I recorded on camera was Horizon Zero Dawn. I of course enabled all the detail to the max and enjoyed the super smooth movement. I also tested few more games, but I didn't record them on camera. Generally everything ran very well at 1080p, so I'm pretty sure this PC will last a few years before any replacement is required. I think the biggest jump in performance will come with 3nm technology for both CPUs and GPUs, which should be available around 2023-2024, so that will be the time to upgrade from this PC. But until then, this should do just fine. So this was my last build in 2021. I hope you liked it, and I also hope that the future owner of this build likes it as well. If you have any questions about it, please leave them in the comments below the video. And from me, that's it. So thank you for watching, and see you in the next one.